Students who have mastered the composition of the numbers 1 through 10 and gained a strong conceptual understanding of difference and distance will have no difficulties mastering subtraction within 10. Compensation is a very powerful strategy in subtraction, just as it is in addition. Rather than keeping a constant sum, compensation in subtraction involves keeping a constant difference or distance. We have already seen that we can find the difference between two quantities by removing one item at a time from each group until there are no items remaining in the smaller group. In this case, the difference between 7 and 9 is 2. The difference between the two groups remains constant as we remove one item at a time from each group. The difference between 7 and 9 is 2. The difference between 6 and 8 is 2. The difference between 5 and 7 is 2. The difference between 4 and 6 is 2. The difference between 3 and 5 is 2. The difference between 2 and 4 is 2. The difference between 1 and 3 is 2. And the difference between 0 and 2 is 2. As long as we add or remove the same number of items to both groups, the difference between the two groups will remain constant. We can use our knowledge of compensation to model subtraction on 10 frames. In this example, we have 3 counters in each 10 frame, representing the subtraction problem 3 minus 3. If we remove 3 counters from each 10 frame, we can see that this is equivalent to 0 minus 0, which is 0. Now we have 4 counters in the top 10 frame and 3 counters in the bottom 10 frame. If we remove 3 counters from each 10 frame, we can see that 4 minus 3 is the same as 1 minus 0, which is 1. Adding another blue counter to the top 10 frame models the subtraction problem 5 minus 3. Keep in mind, students should already know that the difference between 5 and 3 is 2. We want them to understand the concept of compensation, so we take 3 counters out of each 10 frame and we are left with 2 in the top 10 frame. We want students to understand that 5 minus 3 is equivalent to or the same as 2 minus 0. That's why 5 minus 3 equals 2. 10 frames model difference, or the meaning of subtraction in numeration. We also want students to understand the concept of compensation in terms of distance, or the meaning of subtraction in magnitude. This example models the subtraction problem 7 minus 4 on the number line. If we visualize a group of 7 and another group of 4, we know that we can take 4 out of each group and keep a constant difference. On the number line, this is represented by the circles moving in the same direction. Once again, students at this stage should already know that the distance between 7 and 4 is 3. What we want them to understand now is that 7 minus 4 is the same as 3 minus 0, and that is why 7 minus 4 equals 3. The number line also helps to make it clear that subtraction, unlike addition, is not commutative. Order matters in subtraction. A minus B is not the same as B minus A. We may not want to use the technical terms minuend and subtrahend with students, but it is important to be clear about the number we are subtracting from, the minuend, and the number that we are subtracting, the subtrahend. Students do not really need compensation to subtract within 10. However, learning the concept at this early stage will not only help them become proficient with multi-digit subtraction later on, it will also help them to apply subtraction to a wide variety of problem types.